Hello everyone, welcome to ICP DAS's webinar. This is Alla from the International Sales and Marketing Department. We're grateful to have you all participating in our webinar today. Modernizing factory operations is essential for driving innovation, improving efficiency, and staying ahead in today's rapidly changing industrial world. In today's webinar, we will dive into how ICP DAS's tailored solutions can transform your operations, streamline process, and boost overall performance. Get ready to discover practical ways to embrace digitalization and achieve new levels of success in your factory. In today's webinar, we will first explore the importance of digitalization in manufacturing. Following this, I will present 3 case studies demonstrating how ICP DAS has successfully assisted its customers in modernizing their facilities. Let's start by exploring the importance of digitalization of manufacturing process. Digitalization in manufacturing involves moving from paper-based and manual process to digital systems powered by connected technologies. It's a key part of a company's digital transformation, helping businesses stay competitive by adapting to changes in the workforce, meeting higher demand, and improving quality standards. Benefits of digitalization in manufacturing are increased productivity. Digital work instructions and real-time performance data boost productivity on the factory floor. Error reduction. Digital tools and connected machines cut down on mistakes and waste, ensuring accurate ordering and assembly. Data accessibility. Digital systems allow easy access to important data, breaking down information barriers. Optimized operations. Performance data in digital instructions help improve machine operation, maintenance, and task efficiency. Safety improvements. Digital instructions and IoT data provide better safety measures for workers handling machinery. In this part, I will present 3 case studies showcasing how ICP DAS empowers factory digitalization. Let's begin by exploring the first case study, Innovating Automobile Wheel Manufacturing Plant. The customer in this case study is a plant that makes automobile wheels. Previously, the plant's management team had to closely monitor each stock light to check the status of every machine. This process was challenging due to the large number of stock lights, making it difficult to accurately read and interpret information. As a result, critical emergencies could be missed if the changes in the lights were not promptly noticed. To address the listed issues, ICP DAS implemented a comprehensive solution by helping the customer collect data from stock lights and transmit this data wirelessly via Zigbee modules to the PLC. The PLC, guided by ICP DAS's UPAC, manages stock lights to clearly display each machine's status to management staff. Zigbee was chosen for its reliability in high-interference environments and to avoid shutting down machines for wiring, thus reducing operational disruptions. For those who prefer to avoid programming complexities, ICP DAS recommends the MDC714 Modbus Data Concentrator. This device simplifies data collection and integration, making it easier for users to manage without needing to handle the programming required by UPAC. The ZT2550 Zigbee coordinator and ZT2551 Zigbee router transmit stock light data wirelessly to the PLC. They seamlessly convert RS 232.485 interfaces into reliable Zigbee networks, offering extensive transmission range and robust connectivity. With support for 16 channels and thousands of PAN IDs, they are designed to expand a user's network effortlessly. With Zigbee Pro protocol support and a user-friendly Windows graphical interface, setup and management are easy. Additionally, up to 255 routers can be managed in a user network for maximum scalability. The ZT2060 Zigbee router also transmits stock light data to the PLC. This router is designed for reliable connectivity, offering extended transmission range and adjustable RF signal strengths. Configuration is simple, using rotary and DIP switches or a Windows graphical interface. The ZT2060 ensures secure communication with AES 128 encryption and expands network coverage with ZigBee repeater functionality. With 6 digital input channels, 4 relay output channels, and ESD and a surge protection, it's a robust solution for users seeking secure and flexible ZigBee networking. The UPAC 7186 EGD directs the PLC to manage stack lights, clearly displaying each machine's status. This pack is equipped with RS-232-485 ports and is designed to meet diverse industrial needs. It supports I/O expansion through export and offers robust communication with Modbus Serial, Modbus TCP, IP, and Modbus Master protocols. This pack also enables remote I/O capabilities and user-defined protocols, making it a comprehensive solution for users seeking flexible and scalable control in their systems. However, it is important to note that in environments with significant interference, ZigBee might not be the optimal choice. ICP thus recommends using the RFU433 or LRA900 series modems for reliable communication. The RFU433 modem converts RS-232-485 data for long-range transmission via the 433 MHz ISM band. The LRA900 and LRA900E modems, utilizing LoRa technology, provide transparent long-distance communication for both RS-232-485 and Ethernet devices, ensuring reliable performance in challenging conditions. ICP DAS's solution solves production issues by offering simplified monitoring of stack lights. It gathers data from stack lights and sends it wirelessly to the PLC using ZigBee. This means management can monitor all machines from one place without needing to check each light individually. Reduce operational disruptions. With ZigBee wireless communication, there is no need to shut down machines for wiring. This keeps production running smoothly and reduces interruptions. Enhance reliability. By centralizing and automating data collection, the system ensures stable and accurate data transmission, preventing missed alerts and improving safety and efficiency in a plant. The next case study will focus on modernizing traditional metal casting plant. The customer, a metal casting plant, manufactures components for the automotive, motorcycle, and elevator industries. The production process begins by heating raw materials in a furnace to 1450 degrees Celsius to remove slag and extract molten iron. The temperature is then reduced to 1380 degrees Celsius for casting. However, the customer faced challenges with inaccurate material weight tracking, leading to weight discrepancies in the finished products. Additionally, they lacked access to detailed data on energy consumption and environmental conditions within the plant. These issues prompted the customer to seek assistance from ICP DAS. To address these issues, ICP DAS implemented a streamlined solution. Scales were installed in both the raw material and finished goods areas for accurate weighing. I7188XBD Ethernet packs and X107 expansion boards were added to the control panel. On-site staff weighs materials and press buttons corresponding to different raw material types. The I7188XBD records the weight and serial number, converting data from RS-232 to Modbus RTU for SCADA system integration. The DL100TM485S data logger monitors environmental conditions during smelting, while the PM3133 tracks power information. The SCADA system uses power data to log the start and end times of casting. A VPD173N64 displays real-time information on material weights, casting times, power curves, and environmental conditions. It also signals when to stop heating the furnace. For areas without physical wiring, the RFU phosphorus 3 wireless modem transmits data. Different frequencies are used to prevent interference, with the yellow group sending raw material data to the VPD and the red group collecting finished goods data. All data is then sent to the SCADA system. The I7188XBD and X107 records material weights and serial numbers, converting RS-232 data to Modbus RTU for SCADA integration. The pack is a rugged, reliable solution for replacing PC or PLC devices in challenging environments. Designed for high reliability and PC compatibility, it also offers seamless OEM integration with RS-232 485 communication interfaces, built-in digital I/O, and a watchdog timer. It ensures dependable operation. The X107 expansion board enhances functionality with 6 non-isolated digital input channels and 7 non-isolated digital output channels, providing users with a reliable control solution in demanding applications. The DL100TM485S remote T&H data logger is used for environmental monitoring during smelting process. Its LCD display provides clear readings of temperature, humidity, dew point, and module ID. Designed for reliability, it features a wide power range and IP66 water and dust resistance rating. With the capacity to store up to 4088 records and support for RS-485 communication with Modbus RTU protocol, this data logger offers precise and dependable environmental data logging for various applications. The PM3133 RCT200P Smart Power Meter tracks data on power consumption. It combines power and affordability with high accuracy and compact design. This power meter offers current measurements up to 2000 amperes and voltage measurements up to 500 volts. Equipped with a Rogowski coil CT, it handles a broad input voltage range and includes 2 relay outputs for connecting alarms or lights. It supports Modbus RTU, Modbus TCP, and can open protocols for universal connectivity. The VPD173N64 Touch HMI device displays real-time information on material weights, casting times, power curves, and environmental conditions. It offers a high-resolution TFT color touchscreen and fits standard wall-mount outlets with an IP65 rated front panel. It comes with free HMI Works development software, featuring ladder design for PLC users and the C-language environment for IT professionals. Perfect for upgrading mechanical switches to smart control pads. The ICANN 116 industrial LED display provides information on carbon emissions and smelting process for employees in the control center. It integrates easily with PLC and SCADA systems, supporting Modbus TCP and RTU protocols. It can be controlled remotely via mobile devices and offers 7 text colors for clear visibility, with the capacity to store up to 128 messages and a web-based interface for easy message management through standard browsers. This display ensures flexible communication. It supports text and variables in a single message, has a built-in RTC for accurate timestamps, and displays multiple languages with a 16 cm text height. Once the data is collected by the graphic controller, the Aviva H software on the control center's computer will display material weights, carbon emissions, power curve changes, environmental data, and more. Aviva H is a universal platform for developing SCADA and HMI applications, supporting all Windows runtime platforms with local and remote web-based visualization. It allows users to create advanced graphical displays and access over 250 communication drivers for major PLCs. Key features include OPC UA, OPC Classic, trends, alarms, reports, recipes, and built-in SQL database support. The image shows how the control panel is connected to the scale. The panel's lights indicate different raw materials. On-site workers press a button corresponding to the material they are using, and the data is sent. Inside the control panel, a power supply, an i7188XBD module, and RFU 433 module work together. The i7188XBD collects weight and material type from the scale, and the RFU 433 module transmits this data. The VPD series HMI device is set up in the casting area. The photos show that the factory site is full of dust, so a water and dust-proof enclosure was installed to protect the VPD. Since this part of the plant wasn't suitable for cable installation, the RFU 433 was chosen for wireless data transmission. The images show that the RFU 433 in the foundry area is installed in higher and more open locations to improve the quality of the transmitted signals. ICP DAS offers a power information collection solution using the PM3133 smart power meter and clip-on split-core CTs for easy installation. The system enables real-time power monitoring with minimal disruption, providing a fast and efficient way to gather and analyze power data from machinery. In this case, the PM3133 was installed in the casting area to monitor and record power data throughout the casting process. The Rogovsky coil soft CT, ideal for busway power monitoring, was integrated into the SCADA system, enabling precise tracking of current fluctuations to determine the start and end time of the process. ICP DAS's solution tackles production challenges by offering precise tracking of material weights. It ensures accurate documentation of raw materials and finished products. This prevents loss during transportation, cutting, and casting. With detailed records, customers can compare weight differences for each smelting cycle, improving overall process control. Comprehensive data on power consumption. Detailed records include not only the starting time of the induction furnace, but also precise information on energy consumption and accurate environmental data during the casting process. At the entrance to the control center, an ICANN display was installed to display information about carbon emissions and smelting process for employees. A computer was installed in the control center to collect all data, which will be displayed on the control interface and additionally stored in a database. The Aviva H control interface features tabs including main screen, power trends, furnace comparison, input information, and error messages. The main screen is divided into 4 sections: cumulative carbon emissions information for raw materials, real-time information for the smelting area, recent furnace information, and factory information. The Aviva H system collects data on raw material and additive weights, energy consumption, room temperature, and smelting time for each session. Through regression analysis, it finds the link between raw material weight and energy consumption requirements, and then calculates how room temperature and smelting time affect energy consumption. This data is used to recommend optimal energy values for smelting. A newly installed fixed energy consumption smelting controller allows operators to adjust it according to these recommendations, resulting in low energy consumption, shorter precast cooling times, and increased production efficiency. The new smelting controller was set up using ideal energy consumption equations based on material weight and room temperature. The furnace output was adjusted from full power to holding mode according to the recommended dwell time, reducing energy waste while meeting smelting requirements. Thanks to these adjustments, the melting temperature was lowered from 1509 degrees Celsius to 1444 degrees Celsius, a 65 degrees Celsius drop. Over the first 10 months of 2023, this approach reduced energy consumption by 22% compared to 2022, saving the plant $27,000 in energy costs. The next case study will focus on transforming electric wire and cable factory. The customer, a cable and wire manufacturer, focuses on enhancing R&D for high-value products, optimizing production, and boosting efficiency to stay competitive. They are committed to upgrading their production line with advanced IoT and SCADA systems for improved performance and maintenance. However, they face challenges with IoT network integration, OEE visualization, real-time failure prevention, proactive maintenance, and manual transcription and data entry errors. These issues lead the customer to approach ICP DAS for solutions. The factory uses 300 types of I/O communication and motion control modules. Previously, data such as raw material weights, liquid temperatures for drawing machines, and other parameters were collected and transmitted manually, resulting in numerous errors and difficulties in tracking information. ICP DAS was assigned specific production optimization goals, including improving equipment availability, expanding real-time quality monitoring, optimizing product traceability, increasing control over raw material costs, and accelerating the transfer of production knowledge. To solve the initial process challenges, ICP DAS deployed a comprehensive solution. The M7015PG RTD input module automates parameter adjustments using real-time data, reducing manual control and improving data transfer. The NS205A industrial Ethernet switch ensures reliable network communication for uninterrupted data flow and effective quality monitoring. To combat frequent machine downtime and low utilization, the PMC5231 IoT Power Meter Concentrator and PM3133 Smart Power Meter monitor power usage and equipment performance. The UA2241M IoT Communication Server integrates data from various sources for centralized control, enhancing machine utilization. Additionally, the AR200 accelerometer data logger tracks vibration data, and the GIM100 Bluetooth LE Gauge Master transmits Mitutoyo gauge data via Bluetooth. The final plant-wide solution, detailing the location of all ICP DAS devices on the plant layout, is shown in the diagram. The client's main requirement was to visualize equipment availability across the entire plant, including upgrades to overall machine status, availability, performance metrics, production targets, current work order status, real-time monitoring of key parameters, trend analysis, and alarm notifications. The major project outcomes include a 20% increase in machine availability after process improvements, 10% time savings due to data logging replacing manual entry, a 9% reduction in human errors through AI-driven parameter adjustments, providing staff with a longer window to take action and reduce potential machine downtime, and the establishment of a digital transformation platform for power optimization, benefiting the entire corporation. The PMC5231 IoT Power Meter Concentrator reads and records data from the PLCs and RS485 devices. It operates through web browsers without requiring additional software, displays real-time and historic data, logs information to a micro SD card, and sends updates to the control center. Key features include a built-in logic engine for power management, alarm notifications via line or email, and support for Modbus TCP, RTU, SMNP, FTP, and MQTT protocols. It also integrates seamlessly with cloud platforms such as Microsoft Azure, IBM Bluemix, and ICP DAS's IoT Star. The PM3133 RCT1000P smart power meter monitors machinery power data using a Rogowski coil soft CT, enabling easy installation in both large and confined spaces. It offers true RMS power measurements, energy analysis, and total harmonic distortion monitoring. The meter includes two relay outputs for alarm notifications and support Modbus RTU, Modbus TCP, and can open protocols for seamless integration. Additionally, it provides universal data formats for flexible application. The UA2241M IoT communication server bridges IT and OT systems, allowing remote access to I/O modules via Modbus TCP, RTU, ASCII, MQTT, and Ethernet IP protocols. It converts I/O data to OPC UA and MQTT for seamless communication with MES, ERP, SCADA, and cloud services. The server supports data logging to both remote and local storage with offline recovery capabilities, integrates with major cloud platforms, and offers features like MQTT, Broker, HTTPC security, and PID logic for advanced control and automation. The IOP760 Ethernet UART to Wi-Fi converter facilitates data exchange via Wi-Fi, Ethernet, and UART interfaces, making it ideal for wireless M2M applications. It supports dual-band Wi-Fi with automatic roaming to ensure optimal signal strength and compliance with multiple Wi-Fi standards. The device features two LAN ports for connecting local Ethernet devices and an RS-232/485 port for Modbus RTU communication. Additionally, it includes digital input-output for device triggering or event reporting. The IOP760 is housed in a sturdy, easy-to-mount metal body for reliable performance. The M7015PG RTD input module measures machinery temperature using up to 6 RTD sensors, supporting multiple sensor types per channel. It offers precise 16-bit resolution with automatic 3-wired RTD compensation, lead resistance compensation, and open wire detection. Designed for reliability, it features ESD protection, isolation, and dual watchdog functionality. The module supports Modbus RTU and DCOM protocols and is easily configurable via software for flexible integration. The GM100 Bluetooth LE Gauge Master enables wireless data transfer from Mititoya gauges via Bluetooth Low Energy. It integrates smoothly through the SPC interface with a range of up to 20 meters on the 2.4 GHz frequency band, featuring adjustable transmission rates, the trigger button, and the foot switch connector for data logging. It offers flexibility and convenience. Powered by a long-lasting rechargeable battery. It includes status LEDs and is compatible with an Android app for easy data acquisition and remote storage. The image illustrates an application where a measurement system integrates the ICP DAS's GAM100 with digital measuring tools such as Mititoya LVDT, Liner Variable Differential Transformer, and the Mititoya Digital Caliper to collect precise measurement data. The GAM100 is connected to the measuring tools via an SPC statistical process control cable. The collected data is wirelessly transmitted via Bluetooth to a smartphone or tablet. The data can then be further transmitted via Wi-Fi or the Internet to a computer, where it is stored in a MySQL database system. This setup allows for real-time data monitoring and analysis, facilitating efficient and accurate measurement process in various industrial applications. The ER200 data logger monitors and analyzes machinery vibrations, supporting 2 or 4 IEPE inputs with a built-in excitation for accelerometers. It offers adjustable sampling rates and records data on a micro SD card with multiple trigger options, including push button and scheduled modes. Designed for durability, it features strong ASD protection and operates across a wide range of input power and temperatures, ensuring reliable performance in harsh environments. The image illustrates the application of the ICP DAS's ER200 device to measure vibration signal in an industrial environment. The ER200, connected to an accelerometer, captures vibration data from various industrial machinery, such as conveyors, CNC machines, and bottling lines. The collected data is stored on a micro SD card within the ER200 and can be transferred to a computer via an Ethernet connection for further analysis. This setup enables detailed vibration analysis, helping to monitor machine condition, predict maintenance needs, and ensure smooth operation in manufacturing process. ICP DAS's solution addresses the production process challenges by offering the customer seamless IoT network integration. ICP DAS successfully connected various machines like drawing, stranding, and extrusion units into one IoT network. This made data collection easier and improved real-time communication and efficiency across the production line. Sophisticated OE visualization and monitoring. With an advanced SCADA system and Visual Operations Center, ICP DAS improved how OE is viewed and monitored. This provided real-time insights into production performance, helping managers make better decisions and oversee operations more effectively. Advanced maintenance and failure prevention. ICP DAS introduced advanced monitoring and data analysis tools that transform proactive maintenance. The solution allowed automatic machine adjustments and real-time equipment analysis, reducing the risk of failures and optimizing maintenance schedules based on accurate data. Enhanced accuracy in data entry and transcription. Digitalizing the information gathering process minimizes manual errors and tracking issues. Data is now analyzed with software, shifting from experience-based setting to data-driven adjustments. This accelerates the transfer of expertise and reduces knowledge gaps. In conclusion, ICP DAS has effectively advanced factory digitalization across various industries by implementing tailored, cutting-edge solutions. For automobile wheel manufacturing plant, ICP DAS simplified machine status monitoring with Zigbee wireless communication, enhancing reliability and reducing disruptions. At the metal casting factory, they tackled challenges in tracking raw materials, finished goods weights, and energy consumption through integrated weighing systems and SCADA solutions, boosting production accuracy. For the cable and wire manufacturer, ICP DAS enhanced IoT integration, OE visualization, and proactive maintenance with IoT devices and advanced SCADA system. Through these tailored solutions, ICP DAS has demonstrated its capability to drive significant improvements in operational efficiency, accuracy, and control, showcasing the transformative impact of advanced industrial technology. Thank you for joining our webinar today. Please remember to scan the QR code and fill out the questionnaire. Once you are completed, we will send you this presentation. We will now move on to the QA session. Feel free to ask Kevin any questions you might have.